Hello everyone, in this last and final unit we will be discussing functions. So the first thing we need to do is define what is a function. A function is a rule of matching elements in which an input value from this first set only has one output value from the second set. So what does that mean for you in terms of an ordered pair? That means every value of x has a unique value of y. So basically what this means is your x values cannot repeat themselves. You don't really care about the y values in terms of whether or not it's a function. Y values can repeat, but your x values cannot repeat. So this is an example of a function. Notice you've got 1, 2, 3, 4, 5. I didn't even look at the y values. All I cared about was the x values. Now, let's say you had another ordered pair in here that was maybe something like 2, 7. If you have ordered pairs that both start with the same x value, this would be an example of not a function. So hopefully that clears up the difference between a function and not a function. So even if you're looking at it in forms of like a table, notice that each one of these x values here, this is considered your input or your x values, or your domain is another way of putting it. They all have one corresponding y value here, whereas this one, look at the number 5. You see how 5 branches off to 4 and 5 branches off to 7. This 5 would repeat itself twice then, thus it would not be a function. There is such thing as function notation, and so you read this as f of x is equal to 2x, or equal to whatever equation you have over here. F is essentially the name of the function, x tells you the input value, and this is what's happening to the input value. So whatever number you're plugging in for x is being multiplied by 2. This is the same thing as saying y equals 2x. Again, this is just function notation versus this is like written as you would like a linear equation. Now, if you do have a graph and you're trying to determine whether or not the graph represents a function, you can use something called the vertical line test. What that means is if you drew a vertical line anywhere through this graph, notice how it only touches the graph itself one time. So if you took this one and drew lines through it, it's only going to hit at one point. Same thing here. But notice something like a circle, regardless of where I draw the vertical line, like take the number -2. -2 has a value here at about 4, but -2 also has a value down here like -4, or approximately. And so notice how it's going to touch it twice. This is an example of not a function. Same thing here. If I drew any vertical line, that x value is going to have 2 corresponding y values. So this is an example of not a function. So let's just do some examples of, is it a function? Is it not a function? Again, all you want to do is look at your x values. And so you've got -1, 1, 8, and 2. As long as those don't repeat, then yes, this is a function. You've got 3, -1, 4, 3. That's a red flag. I could pretty much stop right there. Because I have the point 3, 0, and because I have the point 3, -1, no, this is not a function. Is this a function here? Do that vertical line test. So draw it wherever you want to. Notice it's going to touch it more than once. So no, this is not a function. Now, no matter where I draw a vertical line on this graph, it's only going to touch that graph one time. So yes, this is a function. And same here, no matter where I draw the vertical line, then it's only going to touch it one time. So yes, this is a function. Notice really the only thing you have to be careful with is where you have kind of this circular, like this loop shape, where you've got a point at the top and a point at the bottom. This is going to be an example of not a function. Now, with functions, we have something called domain and range. So your domain are all your possible x values. Your range is all your possible y values. All right, let's look at some examples of domain and range. So if you're just given some ordered pairs, your domain is all of your x values, so -1, 1, 2, and 10. Your range is going to be all of your y values, so 7, 9, and -3. Notice I didn't write 7 twice, so anything that repeats in terms of your range, you do not need to write that twice. Now, if you do have any type of square root, the one thing you do not want is you do not want negatives underneath your square root. So in terms of your domain, you're essentially asking yourself, what are the bad values that would cause this square root to be equal to a negative number? Well, think about it. X in this case, it could be equal to -6 because that would make your square root equal to 0. But one thing it couldn't be would be, for example, -7, because if you had -7, that would make this equal to -1, which is no good. So basically, -6 is kind of your stopping point, and it's got to be everything greater than -6. So we would say our domain is x such that x is greater than or equal to -6. It could be -5, -4, -3, going on forever, but it can't be anything less than -6 because that's going to cause this to be equal to 0. In this case, since -6 is kind of your starting point, if you did plug in -6, notice you do get 0. So my range is going to start at 0, and then it's going to be every number that is greater than 0. Now, in terms of rationals, so if you have this fraction here, keep in mind your domain, you do not want your you do not want your denominator cannot be equal to 0. So, what are we talking about here? X could be anything under the sun as long as it's not equal to 3. So, X could be less than 3 or X could be greater than 3. It just cannot be equal to 3. Now, your range in this case, kind of think about what this could be equal to. You could pretty much make any number under the sun, 20 divided by something here. But the one number that you can't make in this case is going to be 0. Because in order to have 0, 0 would have to be in your numerator. It would be 0 divided by something. Since you have the number 20 up here, then 0 is not going to be an option. So my range could be, f of x could be anything that is less than 0, or f of x could be anything that is greater than 0. Now, in terms of a graph, when you're looking at domain and range, your domain is all of your x values. So we got to look this way. So in terms of this graph down here, x could be any positive number, x could be any negative number, and it'll still end up on this graph. So my domain is going to be all real numbers. My range, however, does have a starting point. So if you're looking vertically here, notice on this graph, in your y-axis, it starts down here at -5. And then every point above that would be on this graph here. So my range is going to be f of x such that it is greater than or equal to -5. Notice like -6 would not appear on this graph, so that would not be part of my range. Now, in terms of matching functions to their graphs, essentially you're just graphing like you've done in previous units. So if it's something that is linear, you can certainly use your graphing calculator. You could use the fact that this is your y-intercept and this is your slope. But if you're not comfortable with any one of those methods, what you can always do is take numbers and plug them in. So I could take, for example, 0 and plug it in for x. 2 times 0 is 0. 0 plus 1 is 1. I could then take 1 and plug it in for x. So 2 times 1 is 2, plus 1 would give you 3. Once you have two ordered pairs and you connect them, try to make it as oh man, that was kind of ugly, but you guys get the point. Once you connect them there, that would be your graph. And so if this is a multiple choice question, you can just kind of play around with your ordered pairs here to see which ones would actually end up on that graph. Let's look at another example here. Now, if you're doing the method of just choosing points, when you're dealing with a fraction, 0 is always going to be your best friend. Because if I do 1/3 times 0, that's 0. 0 minus 3 is -3. The other number that will be your best friend will be the denominator. So if you plug in 3 as x, 3 times 1/3 actually just gives you 1. So any whole number times that fraction, when that whole number is the denominator, it's just going to leave you with the numerator. So 1 minus 3 would give you -2. So then I would, of course, graph these here. That's 0, -3. 3, -2 is here. And again, I would just be looking for a graph that would match up with mine here. Now let's look at graphing parabolas. You can always tell that an equation is going to graph as a parabola when it has a quadratic form of its equation. It's easily distinguishable because you'll always have this x squared term. So it usually goes x squared, then something x, and then plus or minus some number here. Now, one thing you want to determine when you're graphing a parabola is either its highest or its lowest point. This is called its vertex. The formula for the vertex of a parabola is negative b over 2a. So take, for example, this example here. Negative b would be the opposite of negative 2, which is just 2. And then 2 times a, keep in mind a is 1, so 2 times 1 is just 2. So 2 over 2 gives you 1. That means x is equal to 1. So in order to find y, what they're doing down here is they're plugging in 1 for x and doing 1 squared minus 2 times 1 plus 3. And that gives you y is equal to 2 in this case. That will determine whether you have your highest or your lowest point. Now, another thing you want to determine with a parabola is, this is not the mathematical way of saying it, but whether it smiles at you or frowns at you. So whether it opens up or whether it opens down. You can always tell that by the number that's in front of x squared. If the number in front of x squared is positive, it will essentially smile at you or be positive. If the number in front of x squared is negative, it will essentially frown at you and it will open downward. So let's look at some examples. What I would do first would be to establish what the vertex is going to be. So again, the vertex, we're going to do that negative b over 2a. So negative b would be the opposite of negative 2, which is positive 2. 2 times 1 is just going to be 2. And so 2 over 2 is going to give me x is equal to 1. Now I'm going to take that 1 and plug it in. So this is going to be 1 squared minus 2 times 1 minus 3. So this is 1 minus 2 minus 3. So this is negative 1. Negative 1 minus 1 is going to give me negative 4. And so that means y is equal to negative 4. That's always going to be my starting point. This is either going to be my highest or my lowest point. Now think about it, what it's going to do here. If this is positive, that means it's going to smile at you. That means it's going to open up. So we do know that my parabola is going to be this shape here. What I would do at this point is just pick another number to plug in other than 1. You've already plugged in 1. So pick 2, for example. If I plugged in 2, this would be 2 squared minus 2 times 2 minus 3. So this is going to be 4 minus 4 minus 3. And so 4 minus 4 is 0. 0 minus 3 is negative 3. So when I plugged in 2, I got negative 3. So that's going to be another ordered pair. And then take another number to plug it in. So say, for example, we plugged in 0. Now this should be a mirror image of each other. So 0 should give me negative 3, but just to check, if I do 0 squared minus 2 times 0 minus 3, this is 0 minus 0 minus 3, which is negative 3. And so there would be my other ordered pair. And you can simply just, whoo, that's ugly, but we get the point. You can graph your parabola from there. All right, let's look at another example. So let me erase this guy here. So with this one, again, I want to establish what my vertex is going to be. So I'm going to do negative b over 2a. So the opposite of b is going to be negative 4. And then over 2 times negative 1, because keep in mind there's a negative 1 here. So this is going to be negative 4 over negative 2, which is going to give me a positive 2. That means x is equal to 2. Now we got to figure out what y is going to be equal to. So I'm going to plug in 2 here. This is negative and then 2 squared plus 4 times 2 and then plus 3. So this is going to be negative 4 plus 8 plus 3. So it's going to be 4 plus 3, which is going to give me y is equal to 7. So we've got 2 and then 7's right here. Now keep in mind what this is going to look like. Since this is negative, it is going to frown at you or it's going to go down. Now I'm going to plug in, for example, let's do 0. 0 is always a good one. This is negative 0 squared plus 4 times 0 plus 3. This is just 0 plus 0 plus 3, which is going to give me 3. Again, it should form kind of a mirror image of each other. So let's choose 4. 4 should also give me 3, but just to check. So this is negative and then 4 squared plus 4 times 4 plus 3. So this is going to give me negative 16 plus 16, then plus 3, which is still going to give me 3. So here's 4, 3. Now I've got enough points to kind of sketch out my parabola here. And there we go.